Good morning, everyone. I think I am audible, right? And let me share my screen. And just remember,
Yesterday's class, your volume was so low.
my volume is so low. Yesterday,
Yeah.
okay, I think my volume have not increased as part of my laptop. So I'll make sure I'll not repeat this. Actually, now it is 100%. Volume is there. I've just verified. Okay, so that's sorry. Like thanks for the information, and I'll make sure that okay, my voice is being very clear. Okay. So I think you have observed this in YouTube.
Yes.
Okay. Okay. So now let me go to the creation of. Before going to the creation of AWS account, and I want to explain a the architecture of microservices. Okay, so how the microservices architecture looks like actually. Now let me take an example and explain you what is microservices, what is monolithic application. Okay, suppose let me take an example of monolithic application.
So
Yeah,
Your voice is echoing, breaking your voice.
my voice is breaking.
Background noises.
Background noise. Okay, that's fine. Actually, it's plug in my headphones. Okay, is that fine now?
Yeah, now it's audible.
Yeah. Okay, so let me take this and let me remove this actually diagram. Suppose this is going to be a Amazon.in application. Okay, this is going to be a Amazon.in application. Let me label it as Amazon.in. Okay, so what are the different functionalities that this Amazon.in application will be having? Okay, one functionality is payments. Okay, one functionality that you can perform as part of this Amazon.in application is payment. That means after selecting the item in the Amazon.in application, you can do the payment. Okay, payment functionality. The second functionality, cart. That means you can add the items to the cart once you select it, right? So the next component or the next functionality like that, we have clothing functionality. Okay, the next component we are going to have is, let's take electronics. Okay, like that, Amazon.in application will be having multiple functionalities. Let's stick to this 4 different functionalities. Okay, so here I am discussing about monolithic application. Something like this, monolithic application. Okay, what is this? What is the meaning of this monolithic application? Monolithic application means all the functionalities of this Amazon.in application will be created as a single application, only one application. Okay, all the functionalities will be created as a single application. All the functionalities of this application will be created as a single application. Only one application will be there which contains all these functionalities. Okay, that is the monolithic application. Okay, here next day, after few days of creating this Amazon.in application, there is a new bank that has been come into the market. That bank name is XYZ. This is the new bank that has been come into the market. What the Amazon people decided is, Amazon people want to allow the payments from this bank. Amazon people want to allow the payments from this bank actually. Okay, so Amazon people want to allow the payments from this bank. Here, if they want to allow the payments from this bank, the code is written as part of this payments functionality. The code is written as part of this payment functionality. All the allowed banks, which banks should be allowed to do the payment, all these things is being written as part of the payment functionality of this monolithic application. Suppose in case of monolithic application, what are the disadvantages? In case of monolithic application, if we change the code of this payment functionality, okay, so why I am changing the code? Because I am adding a new bank as a developer. Amazon.in people will be adding a new bank to allow the payments from this bank actually by the customers. Okay, so if you change the code of this payments functionality, you need to change the code of the other functionalities that are there as part of this Amazon.in application. That means you need to change the code of this cart functionality. You need to change the code of this clothing functionality. You need to change the code of this electronics functionality. You need to change the code of all the functionalities. If you disturb, if you do any changes in one functionality, you need to change the code of this all other functionalities that we have in as part of this Amazon.in application. Here the only change I did is part of the payments functionality, but in the case of monolithic applications, you need to change the code as part of all other functionalities. Why you need to change the code? Because all these functionalities are depend on each other. Payments is depend on cart is depend on payments, clothing is depends on payments, and electronics is going to be depending on payments actually. Okay, so if to in order to add one functionality as part of this payments, okay, as part of this payment, but a small change as part of this payments, I also need to work on all other code which is not part of our change actually, like card, clothing, electronics. Okay, so because these functionalities of this Amazon.in are dependent on each other, cart is dependent on payments, clothing is dependent on payments, electronics is dependent on payments, right? So all other functionalities code also need to be changed. Okay, so as a developer, Amazon people took some time and changed the code, changed the all the even though it's changed for payments functionality, as they are dependent on each other, they have changed the code for all other functionalities. They have changed the code for all other functionalities because that is needed, okay, in case of monolithic application. But here, what's the problem? Okay, first problem is time consuming, because doing one change in different functionality, changing the other code in different function, it's not a feasible time, right? It is going to take much time and much efforts. Okay, this is the first problem. And the second problem is really important. Suppose I want to update this application. I want to deploy this updated application on the server. I want to deploy this updated application on the server. Because of the change in this payments functionality, I have changed the code as part of all these functionalities as part of this Amazon.in application. All entire application need to be restarted, which for simple change in the payments functionality. Okay, this, suppose let's think this is the server, this is the server. In order to reflect the changes in the server, okay, you need to restart entire Amazon.in application in case of monolithic. Okay, so if you want to restart Amazon.in application, here you did change only for payments, like actual requirements is only for doing payments, but you changed all the functionalities and you need to restart all the code, all the application as part of this on this server actually, because entire application has been changed because of this payment functionality change, right? So just observe here, restarting entire application, just think it is because it's a very big application, it's an enterprise application, it is going to take 20 minutes of time. Okay, let's think. Okay, MINUTES minutes of time to restart. Just think, in order to add this simple bank as part of this payments functionality, we need to restart entire Amazon.in application, and it is going to take 20 minutes of time to restart and run properly. After running also, we may not know it might be affected. Okay, it might be we may not know it will be working properly or not. Okay, we should again recheck, perform checks, or perform testing on that application, all these things. Let's think 20 minutes is going to be taken to run into running state actually, okay, as part of the server after doing the changes. Just think how much business impact for the Amazon.in people. Okay, so 20 minutes site is down. Okay, so that means how much business impact the people are going to get. Okay, so this is the second disadvantage that is going to have if you use monolithic application. Okay, like that we have many disadvantages. One other disadvantage is, if you choose one programming language, suppose I have chosen Java, all the functionalities need to be developed in the Java only. I cannot develop payments in the Java and the cart in the other .NET, something that it cannot be developed something like that. Okay, all the functionality, if you use one programming language, every entire Amazon.in application should be developed in one programming language only. That's it's not a flexible. Okay, that's a other disadvantage. The third disadvantage, like that we have many disadvantages in case of this monolithic application. Because of these disadvantages that we have in case of monolithic application, we have microservices that has came into the market. What are microservices? Instead of creating entire all the functionalities of a single application, that is monolithic application, in the microservices world, each functionality, the payments functionality, is created as a separate application, something like this. Okay, the payments is created as a separate application. Okay, the cart is created as a separate application, something like this. Okay, so the clothing is created as a separate application. Okay, so something like this. And the electronics is created as a separate application, something like this. Okay, so they are created as a separate applications. Okay, so this is a payment application, payments. Okay, this all these functionalities are a single application in the case of monolithic, but in case of microservices, these are separate applications. This is what is this? This is electronics, and this is going to be our what is this? Clothing, cart or cart, and this is going to be our clothing. Okay, clothing application. Okay, these individual applications are called microservices. These individual applications are called microservices, and there will be communication between these microservices, something like this. After adding the cart items to the cart, you need to do the payments, right? Here cart will be contacting the payments application in order to do the payment, and here after selecting the cloths, you need to add the cloths to the cart, right? So you will be having the communication between the clothing and cart actually, and you'll be having the communication between the electronics and cart, and you'll be having the communication between the electronics and payments. You can directly do the payment without adding to the cart also, right? So you can also do something like this. You will be having communication, something like this. So there will be a communication between the applications that are there, actually between the applications that are there. So these are nothing but microservices. So instead of developing all the applications in a all the functionalities in a single application, people decided to develop individual application. These are called microservices. They have break down into different pieces, and individual applications are being developed. These are something called microservices. So in this case of microservices, you can decide, suppose you can decide for the payments you can use Python to develop the program. For the cards, for the card you can use Java. Okay, in this microservices world. Okay, so you can use different programming languages. It's not restricted, you are not restricted to use only one programming language. Okay, in case of clothing, you can use .NET. Okay, something, whatever you want to use, you can use actually, right? Here these are called microservices. Suppose in this case, a new bank has come into the market. The same example which I've taken as part of this monolithic application, the same example I am going to take, that is a XYZ bank. Okay, the XYZ bank has come into the market, and this bank payments also Amazon people want to allow the customers to pay from. Okay, this bank payment also need to be allowed from by the Amazon people. Okay, so sorry, suppose if we add this bank to this payments functionality, as it's an individual application, it's a different application, it's an individual application. Here there will be dependencies between the functionalities, but here, as they are developed as a separate application, there will not be any dependencies between the applications. If you want to add any bank to this payments functionality, you no need of changing any code which is related to clothing, which is related to electronics, which is related to cart. You no need of changing this. Okay, you only need to change the payments functionality, and you need to restart only the payments functionality application. You need to only restart payments functionality application. Now restarting payments application is going to take, here in this case, let's assume on the server it is going to take 5 seconds. Okay, seconds, it is going to take 5 seconds. For the simplicity, let me take 10 seconds. Okay, so from 20 minutes of restart time of entire application to 10 seconds restart time, so how much difference is there between this? Okay, if you same functionality in the monolithic application, I have added the bank, but it is going to take 20 minutes because all other code also need to be changed, because there's a monolithic application. Okay, and they are dependent on each other. But in case of microservices world, okay, so for adding a simple bank as part of this payments, you know of changing other applications code, because they are not dependent on each other, and you can only restart the payments application on the server. It is going to take only 10 seconds, from 20 minutes of downtime to 10 seconds downtime. You cannot also observe this 10 seconds. You are going to observe as part of the Kubernetes. It is not also going to take 10 seconds. Less than 10 seconds is going to take to restart the application with the updated bank, updated code, which is added with the bank actually. Okay, so this is the advantage of using microservices. In this case, why I'm explaining this, because here individual microservice is created as a separate Docker container. What is Docker container? What is Docker image? Individual microservice. Here payments is deployed as a Docker container. Okay, electronics is deployed as a Docker container. Okay, they are going to Dockerize this. Okay, cart is deployed as a Docker container on the server. Clothing is deployed as a Docker container as a server. So what is Docker container? What is Docker image? We are going to see detailed class, dedicated session is there for that. What is the terminologies of Docker? Okay, we are going to see that. I think it's today only we are going to see actually. Okay, so individual applications we are going to create as a separate containers actually. Okay, something like that. That's why we are going to, I'm explaining this from 20 minutes downtime to 10 seconds downtime. Okay, so that's the advantage of using microservices. And here we are going to Dockerize all these individual applications as separate Docker containers actually. Okay, so that's the thing. That's the difference between microservices and monolithic application. Okay, these are the few examples which I have mentioned. Any questions anyone has, please? Any questions? Is that clear?
Yeah, it's clear.
Yeah, okay. Okay, if you have no questions, let's move further and let me discuss you with the terminologies of Docker. Okay, now let me remove all these things, okay, which is not required, just it's an explanation which I have given. Now let me remove all these things. One second, delete it.
So one thing, if anything changes in applications after the testing team will be interact this one.
Or is there anything changes in the application? Yes, testing should be done. Testing should be done, right? Testing team will be
Yeah.
doing testing on that particular updated application, right? Yes. Okay. Yeah, even though the testing team should be is tested your application, we may not know it might be creating a problem on the production servers. Okay, see, many scenarios has been there. Actually, it will be running in the non-prod environment properly, and it will not be running in the prod environment. Okay, it will be running in the non-prod environment, like it will be running properly in the non-prod environment, it will not be running in the prod environment. There are many scenarios in our IT. Okay, so even though the testing is being performed, some issues cannot be caught on testing. Okay, most of the issues are caught, but yeah, few issues, because the production is environment is a live environment where our actual requests are coming. So few times, very less number of times, you will be getting to know these problems will be appeared as part of the production directly. Okay, so that's the thing. Now let me remove this. Okay, now let's discuss various terminologies of Docker. Terminologies of Docker. So here, what are the different terminologies of Docker that we are going to discuss in this case is, see, here, the first terminology is nothing but Docker host. What is Docker host? Okay, so Docker host. What is Docker host? Docker host is the machine on which you have installed Docker. Suppose I have installed Docker on this particular machine. Let me rephrase this. Just the server, I mean to say, machine means server, EC2 machine, virtual machine, whatever it is. I am going to show you how to create this machine and install this machine. But yeah, how to install the Docker also. But yeah, just for that, as of now, just see that I have installed the Docker as part of this machine. You can see that Docker images. Just do not worry about this now. This is just a terminology, and we have dedicated session for these commands. Okay, so I have installed this. I have installed the Docker on this particular machine. So this machine is nothing but Docker host. The machine, just it's a name for that machine. The machine on which our Docker is running. Okay, running is Docker host. Actually, the machine on which Docker is running is called Docker host. What is Docker daemon? Okay, daemon, DAEMON. What is a daemon in the operating system terminology? Daemon is nothing but a background process that will be running in the background, is nothing but a daemon. It's a background process that will be running as in the background. Actually, that is nothing but daemon. In case of Docker also, we have something called daemon. Okay, how you can see that daemon is properly running or not? Docker daemon. Okay, system ctl status Docker is a command that you need to use to check whether the daemon is properly running or not. You can see that daemon is actively running. You can see that here, right? What is a daemon? Daemon is nothing but a background process that will be continuously listening for our Docker commands. Okay, so it's a background process. That will be continuously continuously listening for our Docker commands. Okay, so what is the Docker command? So we are we are using the Docker commands, right? So something like this, Docker images, right? Something like this. So which will be continuously listening for these Docker commands is nothing but a Docker daemon and perform the necessary action. I am using this Docker command, and Docker daemon listened this Docker command, and it understand this Docker command and perform the necessary action that giving some output, okay, something like this, doing something. Okay, so that's a Docker daemon. Docker daemon is a background process that will be continuously listening for our Docker commands. Okay, now what is Docker image? Okay, so what is Docker image? Docker image is nothing but a binary. Okay, binary means it's like a binary in which your application is going to be present, but it will not be in the running state. Suppose let's take an example. Suppose if you want to play any game, what you're going to do, you are going to go to the internet and download the exe file from the internet, and that's a binary, we call it as, just I am calling that one as a binary. Okay, so the exe file which you are going to download from the internet for that particular game is calling, I'm calling as a binary. And when you double click on that name, that binary, then your game will be started. Before double clicking on that, the game is there as part of that binary, but it is not a running state. Here also, Docker image is nothing but a binary in which our applications are going to be present, but they will not be in the running state. Okay, that's a Docker image. Docker image Docker image is nothing but a binary in which our application is going to be present, but not in a running state. Okay, that's a Docker image. Okay, that's a Docker image. Docker image is nothing but a binary in which our application is going to be present, but not in the running state. Now, what is Docker container? What is Docker container? The next terminology that you need to understand is Docker container. Okay, what is Docker container? The running state of Docker image is nothing but a Docker container. That means in the Docker container, the application will be running state. In the Docker image, the application will be there, but not in the running state. But in the Docker container, the application will be in the running state. Okay, that means the running state of the Docker image is Docker container. Okay, that's a Docker container. Okay, so that's a Docker container. The next terminology that you need to understand is Docker repository. What is Docker repository? The place where you are storing the Docker images is nothing but a Docker repository. The place where you are storing Docker images is Docker repository. Okay, so that's a Docker repository. See, the images you are going to store, it's like it's a GitHub, right? You are going to store your code, application code, right? So like that, that's a GitHub repository. Like that, to store our Docker images, we have a repository that is called Docker repository. There are two types of repositories. One is public Docker repository, public repository, and the private repository. In case of public repository, the images stored in the public repository will be available to everyone in the world. Images stored here will be available to everyone in the world. Okay, so we have the private repository, private repository. Okay, in this, okay, so images stored here will be, will be private. We will be seeing as part of practical also. Okay, do not worry. To your organization or the people who has the access to this repository, to your or the people who can access this repository. That's a public Docker repository and the private Docker repository. The place where we store the Docker images is nothing but a Docker repository. There are two types of Docker repositories: public Docker repository and the private Docker repository. Public means it's public. It's images which are stored in the public Docker repository are available to everyone in the world. Images stored in the private Docker repository are the private to the people who can access this repository. So it's a private to the particular organization. So if your organization has some images, you will be storing as part of the private, not public, because you should not share that images with any public any public domain, right? So something like it's a private Docker registry. Now you have one more terminology that is called Docker client. Docker client. What is Docker client? The place from which you are executing Docker commands. Suppose you can see that I am executing from the Docker commands from this command prompt, right? The command prompt Docker. That means in the Linux we call it as terminal Docker images. I am executing. This is something called commands, right? Which is listened by the Docker daemon, right? It's a background process. So the Docker, the place where the place from which we are executing our Docker commands is something called Docker client. So that's a Docker client. The place from which we are executing Docker commands. You need to understand this. These are the different terminologies that we have actually. What is Docker host? The machine on which we have installed the Docker is called Docker host. What is Docker daemon? It's a background process that will be running in, that will be continuously listening for the Docker commands. What is Docker image? Docker image is nothing but a binary in which our application is going to be present but not in a running state. What is Docker container? The running state of the Docker image is Docker container. What is Docker repository? The place where we store our Docker images is called Docker repositories. There are two types of Docker repository. One is public Docker repository and the private Docker repository. If you store the images as part of the public Docker repository, images will be available to everyone in the world. Everyone in the world can use those images. And if you store the images as part of the private Docker repository, that is the private to your organization. That means the people who has access to that private repository can only access the images as part of that repository. What is Docker client? The place from which we are executing our Docker commands is Docker client actually. So these are the different terminologies that you need to understand before moving before moving further in our Docker course. Any questions, please? Anyone has any questions with these terminologies?
So what you're writing on the notepad, we need it. So you'll be giving this notepad.
No, you are going to get the notes once you
Okay.
get the drive
Mm.
access. You are going to get the notes. In that notes, all these things will be there.
Oh, okay. Whatever you have written here.
Yes.
Oh, okay.
Something like that. So yeah. Now
So
let's move
whatever you
towards.
explain, can you give me some example?
Yeah. It will be clear for you as part of the Docker architecture. Just think as it's a theory only. Just examples you are going to get as part of the Docker architecture. The next concept we are moving towards that.
Yeah, thanks.
Yeah. Enough. Let me remove this. Remove this. Now let's discuss the Docker architecture. So how the Docker architecture looks like? All the components which I've explained previously will be combinedly called as Docker architecture. So let's take an example. this is going to be our Docker client. Okay, this is going to be our Docker client. Just a diagram I'm going to say. This is going to be our Docker client, and this is going to be our Docker host. This is going to be our Docker host on which the Docker is installed. Okay, what is a Docker host? On the machine, the virtual machine on which the Docker is installed is called Docker host. Right now, you can see that this is a virtual machine. I have installed Docker on this virtual machine. So this machine is nothing but a Docker host. Now, on this let me label that one so that it will be very clear for you. This is going to be Docker client. Okay, this is going to be our Docker host. Okay, this is going to be our Docker host. Inside this Docker host, what I mentioned, Docker daemon will be running. Systemctl, you can see that systemctl. How to install Docker, I'm going to help you with that, but as of now, just concentrate on architecture diagram. Okay, systemctl status Docker. Okay, now you can see that a Docker daemon is in running state. Okay, it's a background process. Okay, now let me go to the architecture diagram. In this Docker host, our Docker daemon is in running state. This is our Docker daemon that is been running. Now let me label that one as Docker daemon. Okay, now okay, now we have all our Docker images stored as part of the Docker registry. We have all our Docker images stored as part of the Docker registry. What is Docker registry? The place where we store our Docker images, right? That's a Docker registry. Now let me take this. This is our Docker registry. This is our Docker registry where we are going to have our images like Nginx Docker image, Nginx application image, and Tomcat application image, like busybox, like MySQL image. Okay, what are these images which contains the applications but not in the running state? Where you can find these images? You can go to your browser and go to hub.docker.com. Let me go to hub.docker.com. Let me go to this place. This is the public Docker registry. Okay, this is a public these images which are there as part of the hub.docker.com are publicly available. Now let me show you here. Go to the Nginx, search for Nginx. I hope I have told you the how to create an account, okay, yesterday, right? So this is the Docker image. This is a Docker image. See, all these images are there as part of this hub.docker.com. That is a Docker registry. You can see that here. That is a Docker registry which contains Nginx, Tomcat, busybox, MySQL, like that. Okay, if you search for Tomcat, okay, so there are hundreds, thousands of images that are there as part of this Docker image. You can you are going to have this MySQL image. You can see that MySQL image, right? Okay, so here I will be executing the commands from my Docker client. Let me execute. This is going to be my Docker client from where I am going to execute the commands. Let me Control C. Let me clear the screen. Here my Docker client as well as Docker host is the same machine, same virtual machine. Okay, do not confuse. But here I have drawn as a separate components. Yeah. Okay, so do not worry. This is going to be same Docker client is part of Docker host only. So that in order to differentiate you, in order to understand very in a perfect manner, so I have explained. I have drawn in a as a separate component Docker client. Okay, this Docker client will be there as part of this Docker host only. Okay, now I want to, these are some of the Docker commands I want to use in order to show you the examples. Okay, I want to download Nginx image from the hub.docker.com, that is public Docker registry. What is a command? Docker pull is a command with image name. You need to use Nginx is the image name that you need to use. Okay, now first do not worry with the command which I'm going to use. Okay, Docker rm-f. I'm going to explain this command in the next classes, future classes. Do not worry, all these things I'm going to explain in the future, but just I'm clearing my workspace. Okay, so let me clear the screen. Okay, so to download any particular image, what I'm going to use is, okay, docker pull nginx is the command. So docker pull nginx is the command I am using to download nginx image, right? What, let me click on enter. Now it is going to download the nginx image. From where it is going to download? Now let me help you with the diagram. Now what the command I have used, docker pull, okay, docker pull nginx, right? Docker pull nginx is the command I have used on the docker client, right? This command which I've used from here is listened by the docker daemon. This command which I've used here is listened by the docker daemon. Okay, and docker daemon has connected with this docker registry. Okay, and downloaded the image to my docker host, and downloaded the image to this docker host, something like this. It has downloaded the, what is the image name? Nginx is the image name. Nginx is the image name that it has downloaded, something like this. Okay, nginx is the image name that it got downloaded. Who did this? My docker daemon. What is the command I have used? Docker pull nginx. So whatever the command I have typed, that will be listened by the docker daemon. Docker commands which will be listened by the docker daemon, and docker daemon understands this command, and it understood that user who entered this command want to pull the nginx image, want to download the nginx image, and it went to docker registry and downloaded the nginx image from the docker registry to this particular docker host. That's what it did. Okay, now I want to run this image as a container. I want to run this image as a container. How to do that? Now let me go here. Docker, just forget about this command. I'm going to explain very clearly what is docker run command. Docker run command is used to run an image as a container in which our application will be running state. As of now, our image is downloaded, but not in the running state, just it's an image, right? So docker run hyphen name you need to give. You won't need to give the name of the container, just it's an optional. Okay, I am going to give web app. Okay, -d, I want to use nginx. Just forget about this command. Just only keep in mind that this command is used to run the image as a container. That's it. Okay, explanation of this command you are going to get in the future. Okay, so this is a, just click on enter. The nginx image is executed as a container. Now what happened? Now how to list the containers as part of this? Docker container ls. It will list all the running containers. Actually, just now we have executed this container and it is running since 11 seconds just now, right? So now what happened when we use this command docker run? Now let me go to the diagram and let me help you with this. Actually, now docker run hyphen name is equal to web app, and I have used -d I have used, and the nginx is the image name I have used, right? This command is listened. This command which I have used is listened by the Docker daemon. This command which I have used is listened by the Docker daemon, and Docker daemon understood this command, what the user want to do. It understood like user want to run the Nginx image as a container, and Docker daemon understood that command, and Docker daemon checked whether the Nginx image which the user want to run as a container is already there on the Docker host or not. And it has previously downloaded, Nginx image is already there. And what did Docker daemon, what does Docker daemon did? Docker daemon created a container by using this Nginx image, by using this Nginx image, something like this. With what is the container name which we have given? Okay, the web app is a container name that we have given, something like this. Okay, so this is going to be web app. Okay, from the command we have given, if you observe the command, web app is a container name that we have given, right? So web app is a container name that we have given, in which our application, our Nginx application will be in running state. Okay, now how to list the available containers? Docker container ls, all the running containers will be listed if you use this command, docker container ls. But how to list all the images? Docker images is the command. Okay, you to list all the available, all the images that are present on your machine, all the images that are present on your machine. You can see that only Nginx image is there. Okay, so on my Docker host, as of now, only Nginx image is there. As of now, only Nginx image is there, but I want to run the Tomcat image as a container. Now Docker run hyphen name. Okay, name is equal to Tom hyphen D detached mode hyphen, what is this? Tomcat. What is this? Just remember, as I've said earlier, just only keep in mind that you are running Tomcat image as a container. That's it. Okay, what is the explanation of this command? We'll be going to see in the future. Okay, now let me click on enter. Now the image is not there on my Docker host, because the only Nginx image is there on my Docker host. Tomcat image is not there. Docker daemon have checked. I'll explain you as part of the diagram. Okay, now as of now, Docker container ls, you can see that here two containers are running. One is Nginx and the other one is Tomcat. Now what is the command I have used? Docker run Docker run hyphen name is equal to Tom hyphen D Nginx, Nginx is the command that we have. Sorry, Tomcat, right? So Tomcat, right? So this Tomcat, what's the meaning of this command? The user want to run the Tomcat image as a container. Let me write here. Tom hyphen D Tomcat, right? So this command which we are using here is listened by the Docker daemon, and Docker daemon found, checked whether the Tomcat image, Docker daemon understood this command. Docker daemon understood this command and checked what the user want to do. Docker daemon understood that user want to run Tomcat image as a container. Okay, Tomcat image as a container, right? Here, Docker daemon, after understanding this command, Docker daemon checked whether the Tomcat image is there on the Docker host or not. It found that there is no Tomcat image. And it connected to the Docker registry and downloaded Tomcat image on the Docker host first. It has downloaded the Tomcat image. It did not found the Docker host. On the Docker host, there is no Tomcat image as of now, right? It connected to the Docker registry and it has downloaded the Tomcat image, right? Let me help you with that. Tomcat, this is going to be a Tomcat image. Okay, this is going to be a Tomcat image, and this Tomcat image is downloaded, and this Tomcat image is it executed as a container. It is executing as a container. Okay, something like this. Okay, the application name is going to be, the container name is going to be Tom, right? So that's what we have given as part of the command. The application is name is going to be Tom. Okay, so here you can understand that if the image is already there on the Docker host, Docker daemon will be using that image and running it as a container. If the image is not already there on a Docker host, if you want to run that image as a container, then it will connect to the Docker registry and download the image Docker Tomcat and run it as a container. Okay, so whatever the commands you type from the Docker client, that will be listened by the Docker daemon, that will be listened by the Docker daemon, and Docker daemon understands the command and uh, and perform the necessary action for us. Actually, if you type, once again, it is not this one. If you type Docker images, that means Docker daemon. Okay, Docker images, that means Docker daemon is understanding the command, something like Docker images, what the user want to do. It is listened by the Docker daemon background process, and Docker daemon understood this command that user want to list the available Docker images that are present on the Docker host. If the and it listed all the available images, Okay, if you list the images with the Docker images, each and every image will be belonging to, this is a repository, okay, Tomcat, and the tag, what is the tag means? It's a version. Tag represents the version of this image, okay, latest. In each and every image, the image ID, this is something called image ID. When this image got created 7 days ago, what is the size of this image? 465 MB of size that we have. When you create this image, when you run this image as a container, okay, you can list the available containers, Docker container ls. You can see that if you create this image as a container, okay, this command which you have executed here will be listened by the Docker daemon, and Docker daemon will be giving this output for us. Okay, will be giving this output for us. What is this meaning of this output? Is each and every container which is created from the image will be having a particular container ID. This is going to be a container ID, and from which image this container has been created, that's the image name. This is a command we are going to see this, what is this in the future. But yeah, when it is created 4 minutes ago, what is the status of this? Is it is in the running state? On which port the application inside the container is in running? It is running on port number 8080. What is the name of the container? Or that is Tom. Okay, so all these details will be listed for you if you use this Docker. Who is listing who is listing this? It is listed by Docker daemon. Okay, this is how different components of Docker will be interacting together and forming a Docker architecture, something like this. Okay, so anyone have any question? These are the few examples which I've explained, like running the Docker image and container, and yeah, these are the things, but we are going to have more examples in the future. Okay, so that's the thing. Actually, any questions anyone has, please? Is that clear? Is that clear?
This Docker registry is a public
Yes,
registry. So is that my understanding correct?
Yes, it's a public registry, but you can also create a private registry. How to create that, we are going to see in the future. Okay, so
Okay. So for the as we have Docker client and Docker host, do we have for the particular machine system, do we have any Docker registry? Okay.
no, it's
Docker
not like
terminal you can
no, it's not like a GitHub repository, right? So GitHub repository, if you have the code in the remote repository, you can also have the code in the local repository. It's not like that. You don't have any repository in your local system. Okay, your images will be stored as part of the Docker registry in the remote repository only. Okay, it's not, yeah, it's not you'll not be having any repository on your local Docker host. Okay,
And in your last class, you said like you will be creating, you will be showing how to create an ID, some username.
yeah, AWS account you mean to say, right?
Yeah.
Username means what you?
And whenever
Yeah, AWS account. Yeah, go ahead.
I mean, in the last session, you said like you'll be showing how to create it. So you didn't show in this session.
No,
Last
did
test
not
you
show.
said, Shiva, create account in Docker Hub.
Yeah, last time I've said how to create an account in Docker Hub, but yeah, I've already told. I've also told how to create an account. How to create an account in AWS. I've told that I'll be mentioning in the next class. But yeah, today we don't have time to uh, tell you how to create an AWS account. But tomorrow, definitely moving further, you need to have an AWS account. I will be mentioning you how to create an AWS account. Definitely how to create an EC2 machine, how to install Docker in that. All these things I'll be mentioning in the future classes. But yeah, today I might have told, but there is no time for me to explain that how to create an account. But a hub.docker.com account, I have told you yesterday how to create using the sign up option there. I think yes,
Yeah, it's done, Shiva.
it's done. Okay, yeah. Okay.
Okay. And
So
one more thing, like whenever you start the session, you do a recap of previous session.
yes, generally I do in every class. Yes, I'm going to do that. Okay. Sure, definitely. I accept your point. Recap is definitely needed. Okay, so yeah.
Sometime if you miss last session also, at least next session will cover it.
Yes, you're right. You're right.
Just for reminding.
Yeah, sure, definitely. Generally I do, but yeah, sometimes I may forget. That's fine. Okay. So and one more thing, today is last class for the demos. Okay, so if you have any questions, just ask now itself. If not, if you like it, and please go ahead and register for the course. Okay, so that's the thing actually I want to say. Any questions, please?
So the timings you said like after a few days, like 3 days after demo, you'll be changing the timing.
No, not after demo. I am going to take few days or two. Like I cannot say number of days, but yeah, whenever the syllabus matches your syllabus and their syllabus match it together, you are very near actually. We are going to merge the batches actually. So yeah, I'll be mentioning when they are going to be merged. Okay, so your timings is going to be shifted to 9:30 a.m. morning. Okay,
Okay.
in the future.
Okay. The speed, yeah. Now you're following the speed. Only like at some places you're going very fast, but there is a lot of improvement from the first class. Thank you.
Yeah,
Yeah,
because it's
I'm
a new
considering
topic
your
now,
point.
Shiva, so to understanding some take some time because I'm
Mhm.
everyone new to this subject.
Yeah.
Yes,
Mhm.
actually, you are right,
That's the
Sam.
main thing.
Actually, yeah, you people are right, Jagdish and Sam.
Yeah,
Because
because I'm
when
from
I'm going,
non-IT background, that's what to understand. If you go slower so that I can understand, I can practice a little bit. Today the session was quite good compared to yesterday. But yesterday was good, but a bit fast.
Mm.
okay.
That's the only
Shiva,
thing.
one
When
thing, Shiva, sorry. Yeah, I
mhm.
mean, does this cover whole DevOps things, or it's only Kubernetes and
No,
it will
no.
come under the development side, or
No, it comes under DevOps. See, whatever we are discussing, only related to AWS, sorry, Docker, Kubernetes, and Jenkins. And this comes under both DevOps and developer. Nowadays, developer also expected to expected to uh, use these tools, know these tools, right? So it is related to developer as well as DevOps and as well as SRE people also, because we are also covering monitoring and logging. That comes under SRE. So yeah. Okay, and whenever I am going fast, right? So I am remembering your point that I need to go slow, then I am going slowly at that time. So that's fine. Yeah, you'll be going that way. Okay.
You know, like when you are explaining the diagrams, you are very fast at that time. So I wanted to stop, but
Mm-hmm.
you're going in a flow, so I don't wanted to stop at that time.
Mm-hmm. Okay.
But Shiva, sorry to, I mean, I can say actually it was very good actually, because I worked on Kubernetes and Docker and these things actually. I mean, as a
Mm-hmm.
developer only, but I don't understand all these things actually. I used to have only commands and I used to execute, but now I understand actually what it happening internally and everything actually. Really helpful.
Yeah.
I got
Yeah.
so much clarity on that. Those things actually.
Yeah. Yeah, that's very nice actually. You people are understanding. Okay. Okay, and just remember today's last class for demos, and the link is going to be changed tomorrow. If you are willing to join, please join today or tomorrow itself before going to change the link, because you should not miss the session tomorrow. Okay, it is not the word from my side, it is a word from the DURGASOFT side. Okay, whatever they are saying to me, I need to mention, that's it. Okay, because I am also an employee. Okay, so that's the thing. That's a class for today, and we'll meet you in the next class, that is tomorrow at the same time, 10:30, but with the changed link. Okay, so thanks for joining. I'll meet you in the next class. Thank you.
Yeah, sure. Thank you.
Thank you.
Thanks, Shiva. Thanks.
Yeah.